Welcome to Sairam Tribali YouTube channel. Let us discuss continuation of LG fault. After that, we have a LL fault. So LG fault we discussed and we have given example also. If suppose the line touches the ground, what happens? It gives a line to ground fault, and also we calculated fault current and fault impedance value and everything, right? So next is a line to line fault on the unloaded generator, right? So if suppose two lines touches each other, right? If suppose here, as you can see the diagram, two lanes touches each other. What happens? One to one short circuit occurs. You can do the experiment. If you touch phase neutral or two lanes in the transmission, what happens? The equipment, which one? If you want to touch us, right? I mean, like for example, another one example. If the birds touches both the transmission lines, what happens? Automatically the birds will die, right? So because more shock is occurring, and then more electrical power supply, electrical electrons will move into the body of the birds, automatically it will get die. So it touches both the transmission lines, then only it will effect is I mean fault will be there. But otherwise if suppose the it touches only one wire, it will not get shock, or it will not gives any effect, right? So a single line to, I mean, double line LL fault, line to line fault. If suppose for example so there is a village sides and all, there is a one switch box will be there in the substations, I mean under the H4 motor substation. If suppose snake touches inside the box two lines, what happens? Automatically trip off, automatically it will short the both the terminals, both the transmission lines. So that is called as LL fault. See here, this is generator unloaded, right? So impedance with grounded, right? So star connected system. This one is a conductor, B conductor, C conductor. Individuals A is EA, and EB here, EC is here, and IA current is here, right? See, the terminal conditions are the conditions at fault expressed by the following terminal condition. IA is equal to 0, because that is see here, IA is equal to 0. There is no connection over here. And what about IB? IB plus IC is equal to 0, because both the terms are shorted, right? See, like this. So IB plus IC is equal to 0 output side, and VB is equal to VC, right? So those are conditions. Symmetrical component relation, I naught is equal to 1 by 3 IA plus IB plus IC. So everybody knows, for common for all the faults. And if you uh, want to do calculation, just to substitute the values. 1 by 3 into 0 is IA, right? Because there is no this one output connection on load generator. So IB minus IC. So finally you will get A square minus A square IB. So just to substitute 1 by 3 I square minus AIB, if it is IA1 and this one is IA2, here for 0 sequence component you will get 0 answer, right? IA1 will get same, and IA3 also will get same, but yeah, J operator, I mean A operator will be different. So you can say IA0 is equal to 0, IA2 is equal to minus IA1, because reverse. See here, A minus A square will be there, here A square minus A will be there, right? So regarding sequence terminal voltage, VA1 is equal to what? 1 by 3 VA plus A VB plus A square VC. This is a matrix term, okay? Just to concentrate, VA minus VB will get VA2 is equal to same, VA is equal to 1 is equal to VA2, and IA0 is equal to 0, VA0 is equal to minus IA0, and Z0 is equal to 0, Z0 is equal to 0, VA0 is equal to 0, and VA1 is equal to VA2 in terms of voltage, okay? So interconnection of sequence network is this one is positive sequence, right? And this one is negative sequence, I mean zero sequence. This one, see here, this is positive sequence, this is negative sequence, this one is zero sequence. See, only reactance will be there, and here generator, and this is a first sequence, right? So current will be flowing here, and then this one is fault current here, and this one is zero sequence. So sequence quantities, the following relations can be directly obtained. One is IA1 or minus IA2. Already we derived the equation as I1 IA2 EA by Z1 plus Z2 according to Ohm's law, and IA0 is equal to VA0 is equal to 0. So already we got these values, and VA1 is equal to EA minus IA1 Z1. Just to apply previous slide here one KVL and here on KVL, you'll get all the values according to Faraday's according to Ohm's law. Okay, so finally you get EA into Z2 divided by Z1 plus Z2, right? Next, fault current we need to determine by using Galileo fault. The fault current in this case is IF is equal to IB, IA0, A square, IA1, IA, IA2. Finally, we will get the answer is minus J root 3 IA1. Just to substitute IA1 over here, IA1 is equal to what? EA by Z1 plus Z2. Just to substitute, we will get it answer. And next, we'll discuss double line to ground fault, right? So let's move on to okay. Let's see double line to ground fault, LLG fault, right? On the unloaded generator. See here, this one is an unloaded generator, double line and one ground fault, right? So this one is open, IA is equal to 0. This one is the neutral grounded because this is a star connected unloaded generator. So these are the reactance of armature conductor, EA, EBS, induced voltage in the A conductor, B conductor, C conductor. So the condition is double line shorted and then connected to ground. That is double line to ground fault if IF is equal to IB plus IC. So here there is a fault. Okay, here there is a fault. So that we are going to determine now. So VB is equal to 0, VC is equal to 0, IA is equal to 0, right? These are the 0 conditions in the previous circuit diagram. And a symmetrical component we'll discuss now, right? See in the previous diagram, how it becomes VA is equal to 0. Suppose why this one is 0. See here, if suppose fault occurs in the simple circuit, I mean, if suppose there is a short circuit in the bulb terminal, bulb will not be glowing, bulb will get damaged, voltage becomes 0, current reaches the maximum limit, voltage will be reduced to 0. So that's why, so we have taken here voltage becomes 0 and then VC is equal to 0, IA is equal to 0. Only IB and then IC is a more current and then automatically fault occurs, and it gives effect to the generator as well as transmission lines, right? So this one is a generator. From here, don't confuse, from here to here there is a transmission lines. Okay, if suppose here fault occurs, just to assume fault occurs over here with a ground. Okay, just to consider this one is a generator with the transmission lines will be there here to here.